Next, let's look at TensorFlow Lite for mobile and embedded devices. TensorFlow Lite is a lightweight and optimized framework for deploying machine learning models on mobile and embedded devices, enabling efficient inference with low latency and reduced memory footprint. Let's deep dive into deploying TensorFlow models using TensorFlow Lite for mobile and embedded devices. First one that we'll look at is conversion to TensorFlow Lite format. Before deploying a TensorFlow model to a mobile or embedded device using TensorFlow Lite, you need to convert the model to the TensorFlow Lite format. TensorFlow provides tools and APIs for converting TensorFlow models to TensorFlow Lite format. Example of conversion using TensorFlow Lite converter is right here, where we are first importing TensorFlow HTF, then load the trained tensor model using the load model function provided by the Keras models. Next, we are converting the models to TensorFlow Lite format by calling the from Keras model function and passing the model to it, which is part of the TF Lite converter, which is the TensorFlow Lite converter, passing it to putting it in the converter variable. Next, we are calling converter.convert and passing that model into the TF Lite model instance. Now, once we're done with that, save the converted TensorFlow Lite model into a file by calling with open model.tflite file is the name of the file, and we're writing it to that as f, and we can say f.write tflite model, pass it that tflite model that we created up above. Next is TensorFlow Lite Interpreter. To run the inference with TensorFlow Lite models on mobile or embedded devices, you'll use the TensorFlow Lite Interpreter. This interpreter provides a C++ API for embedding TensorFlow Lite models into mobile apps and a Java API for Android apps. Examples of running inference with TensorFlow Lite Interpreter using Python is here, where I am importing NumPy and TensorFlow. Next, I am loading the TensorFlow Lite model by calling the interpreter function and passing the model path. Next, I am taking that interpreter and allocating tensors. Next, I am to get inputs and output tensors. What you do is put the create two variables, input details and output details, and from the interpreter I'm saying get input details and get output details function. Next, you prepare the input data by calling the np, the numpy, and create an array 1 with four parameters here, four parameters inside an array, and then call the pass the dt type equal to np.float32, so it's float, it knows that's float values. Next, I'm setting tensor for interpreter by calling the set tensor method and passing the input details to it at a particular index, and then I'm saying input data. Next, I am running inference by calling interpreter.invoke. Next, the output data you can get from the interpreter by calling the get tensor and give it the output details value with at 0 at index. So this will print out your output data that from this TensorFlow Lite interpreter. Third one is model optimization techniques. TensorFlow Lite provides various optimization techniques to reduce the size and improve the performance of TensorFlow Lite models for mobile and embedded deployment. These techniques include quantization, quantizing model weights and activations to lower precision. Example, 8-bit integers to reduce model size and improve inference speed. The next one is model pruning, removing redundant or less important weights from the model to reduce model size without significantly affecting the accuracy. Next is operator fusion, fusing multiple operations into a single operation to reduce memory access and improve performance. Next one is selective execution, where what it does is optimizing the execution of TensorFlow Lite operators based on device capabilities and hardware accelerators. Deployment on mobile and embedded devices. Once you have converted and optimized your TensorFlow model to TensorFlow Lite format, you can deploy it on mobile and embedded devices such as smartphones, tablets, IoT devices, and microcontrollers. TensorFlow Lite supports various platforms including Android, iOS, Linux, Windows, and microcontrollers like Raspberry Pi. TensorFlow Lite is a powerful framework for deploying machine learning models on mobile and embedded devices, enabling efficient inference with low latency and reduced memory footprint. By converting, optimizing, and deploying TensorFlow models using TensorFlow Lite, you can bring the power of machine learning to a wide range of mobile and embedded applications, including image recognition, natural language processing, gesture recognition, and more. Consider incorporating TensorFlow Lite into your deployment workflow to deploy machine learning models effectively on resource-constrained devices and create innovative and intelligent mobile and embedded applications.